Hello, my name is Josh Reingold. This is Physics 2212, Lab 1, Charged Tape. The purpose of this lab was to determine the charge and interaction between two pieces of tape, determine how many electrons the tape lost, and then simulate these findings using a GlowScript program. The two primary physics principles used in this experiment are the force due to an electric charge and the force due to gravity. Because the tape is not moving, the net force is assumed to be zero, and therefore if you set these equations equal to each other, you can solve for the electric force, and therefore the electric charge. The main results that came out of this lab was that the tape has a net positive charge of approximately 9.5 times 10 to the negative 7th coulombs, and it has lost approximately 5.93 times 10 to the 12th electrons. The justification for using these specific physics equations in this experiment are as follows. The tape was held above a surface, and therefore the only forces were the gravitational and electric forces. By assuming the tape to be a point charge, this allows the use of the point charge force equation. Other assumptions include that both pieces of tape have identical charge and length, and that air resistance or other environmental effects are negligible. To define the parameters of this experiment, the system will be the two pieces of tape, the surroundings will be the environment and everything else, and the initial conditions are that the two pieces of tape are held at a large distance from each other and that they are both charged. The methodology is that one electrically charged piece of tape will be suspended and the other will slowly be moved towards it until the first begins to lift up. Then the distance between them will be measured and marked down as distance d, as well as the mass of the tape, which will be marked down in kilograms. This is some of the code that was generated for the simulation and modeling part of the lab. These are the results from the coded questions. Some assumptions made for the simulations are that only vertical force acted on the tape, there were no environmental effects, and there was a uniform charge distribution on the tape. These assumptions may have caused the difference between the modeled and experimental results. The resulting data from this experiment in SI units is as follows. The length of the tape was 0.18 meters, the mass was 0.002 kilograms, the distance between the tape was approximately 0.01 meters, the magnitude of gravity in the negative y direction was 0.196 newtons, the magnitude of the electric force in the positive y direction was also 0.196 newtons, the measured electric charge was 9.5 times 10 to the negative 7 coulombs, and the approximate number of electrons lost was 5.93 times 10 to the 12th. This is the free body diagram for the experiment. Because the tape is not moving, the net force on it is zero, and therefore the magnitude of the force of gravity acting in the negative y direction equals the magnitude of the electric force acting in the positive y direction. The final results for this experiment are that the approximate number of atoms in the tape was 2.34 times 10 to the 22nd. The ratio of electrons lost was 1 to 2.53 times 10 to the 10th. And the final assumptions for this experiment are that there was a constant distribution of electrons and number of atoms on the tape, as well as an initial neutral charge of the tape. Some potential error in this experiment is the impact of air resistance, the assumption that the tape acts as a point charge or line of point charges, and that the difference between the lengths of tape. What if electrons were positive and protons were negative? In this case, the fields would switch, negative charge tape, but no effect on the experiment outcome because opposite charges still attract and same charges still repel. Why are the first and second GlowScript models different, and which one is more accurate? The two simulations are different because the first one models it as a point charge and the second one as a line of points, which will create different results. The second model is most likely closer to being accurate, however, it is still idealistic because the actual tape probably has a grid of charge rather than a line.